For the last part of this chapter, we're going to talk about how we might solve problems and make decisions. So when we talk about problem solving, we're talking about a sequential process where we go from some initial problem state to a desired end goal. In order to achieve that desired solution that we have at the end here, we need to sort of choose and select our appropriate strategies and apply those to that situation. Our ability to successfully solve a problem can be influenced by the nature of the problem. How difficult of an issue is it to overcome? It can also be affected by the way that we approach that problem. So what kind of a mindset do we have going into it? How are we going to face it head on? Are we going to think about it? What are we going to do with it? We can also have an influence based on our past experiences. Have we solved a problem like this before, or is this something completely new to us? If we have general knowledge that's relevant to solving this problem, that can help us solve it more quickly and more easily. And then we also want to keep in mind the strategies that we have available to us. What are some of the ways that we might go about solving this problem? What are some of the strategies that we can use to help us do a good job of it? And so we're going to break down some of these aspects that influence our ability to solve problems. So first, let's look at a thought experiment. So this is a problem set that's used to sort of see how we approach problems. So problem A says that we have an unlimited amount of water. So we have a pitcher of water. We can fill that pitcher up as many times as we need to. But our goal here is that we need to get 100 ounces of water into our target cup. So we have 3 cups available to us. We have A, B, and C. A is 127 ounces, B is 21 ounces, and C is 3 ounces. Now, one solution that we could use is we fill cup A, pour that into our target cup, and then we subtract 21 ounces using cup B. That would bring our total down to 106 ounces, and then we could subtract 2 of cup C. So 3 and 3 would reduce 3 ounces and bring us to 100 ounces total. That would be a pretty efficient solution to this problem. So we've chosen our strategy, we know how to proceed. Next, we're faced with a different problem. So this is problem B, and it's the same kind of setup. It says that we have an unlimited amount of water. This time we need to measure 20 ounces into our target cup. So we have a cup that has 49 ounces, one that is 23 ounces, and one that is 3 ounces. So what we might say here is, well, last time we had the largest cup, so we added 49 ounces, and then we subtracted our second largest cup, so that would bring us down to 26 ounces, and then we could subtract 2 of cup C, so we would subtract 3 and then 3 more, and that would bring us to 20 ounces total. That would be another way to solve this problem. But what we've actually encountered here is actually a mental set. So our prior experience, having experienced problem A first, sort of predisposed us to solving this problem the same way. However, we didn't need to use cup A at all. If we take a step back, we could have just used cup B and subtracted cup C. So 23 minus 3 is 20. That would have been a lot less work. But our prior experience and the way that we've solved a problem like this before in the past made us more likely to use the same solution that's worked previously without searching for new explanations, for new answers, even if those new answers might be more efficient. So that mental set that I mentioned gave us this expectation of how we should solve that problem. And our mental set influenced how we approached the second problem. So the first problem created that expectation, and then in the second set, we were sort of limited in how we approached the second problem based on what we had already come to expect. And in experiments sort of like that one, they can do all sorts of different variations of that. And if researchers control if participants experience set A first and then set B, or set B and then set A, they'll find that those that do A first and then B fall prey to that mental set, just like our example. But those who do B first and then A don't have the same problem. They'd find the simpler solution in set B first and not be restricted then when they approach set A. So that example that we just walked through actually shows one of the issues with mental sets, that these can lead to fixations. Basically, our past experience or our expectations of how we should solve this problem end up influencing how we approach new problems. So this narrows or restricts our ability to think of novel solutions. We didn't think of the more efficient solution for set B because we already knew how we had solved it in A, and we applied the same strategy, even though it wasn't necessarily the most efficient strategy. A concept that's similar to these fixations is the idea of functional fixedness. And this is a tendency to view an object as only having one function, the function that it's commonly used for. And we tend to fail to see other possible uses for that particular object. So the example that the textbook gives us is that they have sort of a box set out, and this box is keeping all of the tacks together. They have a set of matches, and they have a candle. And what they do is they ask participants to use the tools they've been given to prevent the candle from dripping wax onto the table when it's lit. And so most people will find a solution that involves sort of pinning the candle to the board that's nearby and using pins to sort of hold it in place and then have it drip wax into the box. But somehow they're using those pins to anchor the candle and have it drip downward onto the box. However, if they do the exact same thing, they have the exact same setup, they even give people the exact same materials, but this time they give them a box, some pins, and the matches all separately, all of a sudden it becomes easier to perceive this box as maybe being a tool that we could use. When they're given separately like this, people tend to stand the candle in the box to prevent it from dripping on the table, which is a much simpler solution. But when we're sort of restricted, when we are fixed on the function of this box as a thing that holds the tacks and all of the utensils that we're using, we tend to be sort of restricted in the scope of what we might think to use it for. So there are lots of examples where we assume that we should only use things for the function that they're supposed to be used for. But we have to sort of pause and step outside the box to start using them for other functions. As an example, have you ever gone to a party and maybe somebody brings a bottle of wine, but nobody thought to bring a corkscrew? So all of a sudden you have to find a way to open that bottle that isn't necessarily using a corkscrew. So you'd have to think of what else could we use? So people might try a knife. And so you're having to use that object, that knife, for something other than the purpose that you would usually think for it. So using it as a lever to sort of pull the cork out. Or maybe you get a screwdriver or whatever you've found to solve this problem. So finding those alternative solutions or alternative uses for those objects is overcoming this idea of functional fixedness. Next, we're going to talk about potential strategies that we can use to solve a problem. Typically, we think of humans as using trial and error problem solving, at least to get started. With trial and error, you would apply a pretty standard sequence of possible strategies until you reach the solution. So you try option 1. If that doesn't work, you try option 2. If that doesn't work, you try option 3, and so on and so forth until you find the option that works. Conversely, we could use what's called an algorithm. So we could apply a precise set of rules that would help us to solve a problem. So maybe we have rules that that help us exclude solutions that we might have tried with trial and error that we know won't work, that we can skip over. So we can use algorithms to sort of use that set in a specific way. Our textbook takes some time and actually talks about how early forms of artificial intelligence were built on this idea of trial and error, sort of brute forcing a problem, because we figured that that's how humans might solve problems, so let's get machines to solve problems the same way. But that's a very energy-intensive technique. It's not efficient for artificial intelligence, and it's not really efficient for humans either. So over time, we can come to rely on algorithms. And just as we as humans will rely on algorithms, so sets of rules that we know help us find solutions and shortcuts to solve problems, we've done the same with our modern artificial intelligence setups, where we've created more and more complex algorithms to try and help computers sort of systematically test out solutions and not necessarily rely on brute force trial and error type processes. And the example that they get you to walk through in the textbook is if you have, I think they have orcs and hobbits that have to get across a river from one side to the other, but you can't ever leave one hobbit alone with the orcs or they'll get eaten. So you always have to have equal proportions of them, or else violence will happen. And they have to, so you have to think about what's the best way to transport them back and forth on a boat with a limited capacity. And so the text walks through sort of how you would go about solving this and what strategies you might use to conduct this sort of thought experiment, but just sort of a visual reminding you of that process. Now, if algorithms are those precise sets of rules that we can apply in a particular order to try and solve a problem, then then that would be closely related to the next concept, which are heuristics. And a heuristic is a shortcut rule that we can apply to try and solve problems. So heuristics can be beneficial because they allow us to find those shortcuts, a quick and dirty solution, if it were. And so it might not lead to an accurate solution, but it can be quick and efficient. So we could even consider that solution to problem B in our thought experiment at the beginning as a heuristic. We knew a strategy that worked, we tried it, and it gave us a solution in problem B. It wasn't necessarily the best solution, it wasn't the most efficient, but it got us there in the end. So it does a good job of illustrating what a heuristic is. And we can have different kinds of heuristics. So we could talk about a means end heuristic, which is where you're trying to keep the end goal in mind. So that goal state where we've solved the problem is our primary focus. And when we're using a means end heuristic, we will take whatever measures necessary to try and attain that goal. But the problem here is if we're so driven and focused on that end state, we might sort of not take into consideration any possible steps that remove us or pull us further back from obtaining that goal. So in our orcs and hobbits taking the boat, in order to successfully solve that problem, there are stages when you have to bring some of the individuals back across the river to the side they started on, because that's the only way to prevent violence. But if you're focused using this means end heuristic, then going backwards like that would be problematic. So you might overlook potential steps that involve moving backwards because you're so focused on moving forward. So if someone is rigidly focused on this kind of a heuristic, it can prevent them from making progress towards that goal state, even if that goal state is their actual intention to reach. So it's sort of a too narrow of a focus and not realizing that there are other steps backward that will help you get there in the end. The next kind of heuristic we're going to talk about is a representative heuristic. And this refers to a situation where the problem solver will mentally compare some object or item to our stored prototype of an event, object, or person. So we're using some of the terms that we used earlier on when we were talking about categorizing items based on sort of what we view as a prototype for that particular group. So here, a representative heuristic is talking about how we go about comparing that new item that we're looking at, so new things that may or may not belong to a group, and we see which groups it fits in based on our stored prototype of those groups. So we might assume that something belongs to a particular category or group because it resembles our prototype, because it resembles that sort of mental thought and representation that we conjure up when we think of that particular group. Now, this can be very beneficial because it gives us that intuition to solve problems quickly. Again, heuristics are those shortcuts, so they're helping us solve problems quickly, but we need to keep in mind that it can also lead us to make errors. So if we are making assumptions based on prototypes, we might be relying on things like stereotypes. So the textbook uses an example where they describe individuals based on sort of traits that might relate to their personality. And then they ask you what job each individual might have. And so it illustrates that if they talk about somebody being sort of shrewd and a good businessman and a fast talker, you might quickly assume that they're a salesperson of some kind. Or if somebody works with their hands and they're hardworking and trustworthy, you might assume that they're a laborer or something like that. So that assumption can be helpful if it's accurate. So we can use those intuitions to solve problems, but we do need to keep in mind that there can be errors because we really are just working with sort of two-dimensional prototypes, which are basically stereotypes. The last of our heuristics we're going to talk about is the availability heuristic. Now, this is a rule of thumb that says we try to accurately estimate frequencies of events based on how difficult it is to think of them. Now, this is important to note that it is an attempt at accuracy, but in fact, this availability heuristic is one of those things where we introduce quite a bit of bias into how we remember things. So some things are easier to remember than others. Some things stick in your mind. They are maybe more salient, more intense, more memorable. And because of this availability heuristic, those things that are more easy for us to recall, we tend to think that they happen more often than they might actually happen. So if you think of so we think about shark attacks. Shark attacks are scary and intense and anxiety-inducing. And so if we see a single shark attack on the news, that's a big event, and we're going to remember that having happened. On the contrast, something like somebody dying because of a vending machine accident, that doesn't seem to be a thing that happens very often. We don't hear about it in the news. It's not something that we think of. And so we might conclude that shark attacks are more common than death by vending machine. But that's not the case. If we look at the statistics, far more people die each year due to vending machines than shark attacks. But because of this availability heuristic, because shark attacks are more memorable and easier to recall, we assume that they happen more frequently. And actually, things like Google have been set up to use something fairly similar to an availability heuristic, where they will return search results based on what is searched most often. So Google doesn't have a unreliable memory. They can actually check exactly what has been searched and pop up what are the most common searches. We just have to keep in mind that with our memories, our memory isn't necessarily reliable, and so we are subject to the biases that come from that. So if those are all different rules and strategies and structures for solving problems in fairly predictable manners, what about finding creative and novel solutions? So the next couple of slides, we're going to talk about the different stages that are involved in creativity. The first of these stages, so step one, is preparation. So in order to prepare yourself to find a solution, you should become as familiar with a topic as possible. And we can look at the example of chess players and whether people are expert chess players or new chess players. So there are so many experiments that have been done looking at this, but the basic idea here is that they'll have people who are new to playing chess. They don't necessarily know all the rules. They don't have a lot of training. They just know what the chess pieces are, and they've seen a chessboard before. They have low levels of familiarity, so we could call them novices. We also can look at then how they compare to advanced chess players, people who have played the game a lot. And because they've played a lot, they've learned to make associations between the pieces. Maybe they look at an arrangement of pieces on the board and they can think about what moves are available to them, what they need to watch out for, and so on. So by having that expertise, they can start making connections between the pieces, whereas the novices just look at the pieces in isolation. Now, if you remember back to our chapter on memory in Psych 104, we would have talked about how those novice chess players tend to remember fewer chess pieces when they're arranged randomly like this, and the advanced chess players can make more associations and they remember more of the pieces and put them in the correct locations based on their experience. So experience and becoming familiar with that topic can set them up to find more solutions, to remember more information, and then to have more info to work with. So preparation can be key. The next step in our stages of creativity is the incubation step. And this is actually when you take a break from effortful problem solving. So you've gained some knowledge, you've built up that expertise, you've looked at the problem from a bunch of different angles, but now you want to take a step back. You might have heard that when you're studying, people will tell you to sleep on it or come back to it later. And interestingly, there are some studies that lend credence to this idea. So there have been studies that demonstrate that sleep seems to help facilitate memory consolidation. So very, very basically, this study was looking at how people were able to solve second tests. So they were given two sets of tests. The first test was usually pretty standard, and then the second test would either be easy or difficult, depending on the group they were in. And they also had 3 different treatment conditions here. So there was a control where people did the first test and then they did the second test, which was either easy or hard. They would do that second test immediately. There was an awake incubation group where they did the first test and then completed the second easy test or second difficult test after an 8-hour period in which they weren't allowed to sleep, but they just sort of did other tasks. And then our third group is a sleep incubation group. So they did the first task, the first test, then did either the second easy or second difficult test after having slept for 8 hours. And the part that we care about here is this second difficult task, which shows that our sleep incubation group ended up performing better than either our control or awake incubation group on that difficult test. So the implication here is that sleeping might have allowed them to discover new solutions by activating different parts of their brain while sleeping. As an alternative, it might be that they just benefited from having rested between the first and that second difficult task. But this is sort of pointing in the right direction that sleep might help people come up with new solutions. Our next two stages are illumination and evaluation. And illumination is that idea of having a sudden eureka moment. So the illumination stage is when you achieve insight or suddenly realize that you found a solution to a problem. This period typically follows a time of sort of pre-awareness when you almost have the idea but not quite. But it seems to be like there's a hard switch between I almost have it and then poof, everything falls together all at once. So that eureka moment, we can call that illumination. When the idea comes together, we have that solution, we've come up with a creative alternative, and it all comes together at once. Usually having ruminated on it or incubated that idea as we're thinking about things. And the last step in this creative process is evaluation. So then we take a step back and decide if we've actually found a good solution or if we need to revisit the process. So did we make a good, or have we found a good solution? Is this a good way to solve this problem? Or do we need to keep considering our options? Do we need to keep thinking about it? For the next couple of slides, we're going to talk a little bit about potential biases in our decision-making process. So things that we should keep in mind, sort of ways that our decision-making process can be led astray. So the first of these is confirmation bias. And this is a tendency for us to only pay attention to evidence that supports our original position while ignoring any evidence that goes against that original stance. So humans tend to seek out information that matches with our existing ideas and beliefs. So we look for things that belong with what we already understand or what we already think. So we tend to like people that agree with us. We're more likely to read news articles that support a perspective that we already believe. It's a lot harder to shift our understanding to look at evidence that goes against what we believe. And we have this tendency to avoid or distort any information that we receive that isn't consistent with our existing beliefs. So if we have neutral evidence, we might distort it so that it's supporting. If we have evidence that goes against what we think, then we might view it as unreliable and sort of ignore its existence. And these are things that can be active or even passive processes. Sometimes we don't know that we're doing it, but we have a tendency to take comfort in things that match what we already think, and we tend to avoid things that go against what we believe. So we need to be aware of this confirmation bias because it can shape what kind of information we're exposed to. And especially as science students, as we're learning how to do science, we want to be aware of these kinds of problems. We'd like to be able to take in information, whether it goes against our beliefs or not, and see if there's evidence that can change our perspective. That's part of that scientific process we spent last week talking about. Another factor that can bias our decision-making is framing. So how we present information can influence the choices that people make. So if we frame a situation as a gain, if we say that we're setting this up so that you're going to win $100, people tend to like a guaranteed gain as opposed to the chance to get a bigger gain versus a lower chance of getting nothing. So actually, let's look at the examples on the next slide. That'll illustrate this a little bit better. But just for what we're aiming for here, is that people tend to take a sure thing, a guaranteed gain, when things are framed as gains. And we tend to be more risky, we tend to take chances in order to avoid losses. So we like a stable option when there's the potential for gaining, and we tend to be risky in order to avoid losses. So the framing of a situation, even if the outcome is the same, if it's framed as a gain or a loss, we will change our decision based on that framing. So there is a subjective difference that can be elicited from how we frame a scenario. So we're going to look at sort of two ways of framing. It's called a game scenario, not because it's meant to be like a fun game, but because of something called game theory, which looks at how people tend to frame and think about decisions in different situations, how we weight odds in order to make a choice. So that's just a little bit of background info on this. But the example that we got from the textbook slides, we can say, which would you choose to combat a new plague on Mars? So would you choose to adopt a new untested vaccine when we know that 100 Martians will definitely be saved? Or we adopt a new untested vaccine and there is a 1 in 4 probability that all the Martians will be saved, or a 3 in 4 probability that none of them will be saved. So do we choose to save 100 for sure, or do we take a risk at saving them all or saving none? Typically, people will choose the first option. We would choose to pick that safe option. We will take the sure thing when it's framed as gaining or saving those 100 Martians. But if we frame the same information as a loss, we have the same setup here. Which would you choose to combat a new plague on Mars? But this time we say you adopt a new untested vaccine and 300 Martians will die. There are only 400 total, so 100 surviving versus 300 dying is the exact same setup. So we're saying, okay, so you specifically choose that 100 of them will die. Or you adopt a new untested vaccine, there's a 1 in 4 chance that none of them die, and a 3 in 4 chance that all of them die. People tend to take the risky option in this situation. The numbers are exactly the same, they're just presented in opposite frames, so as a net gain versus a net loss, but people tend to choose number 2, the risky option, for a loss, and they'll choose number 1 for a safe option because it's framed as a gain. And we can do this with money that you lose or win. We can do this with all sorts of different things, but this tends to be a pretty standard issue with framing, and humans tend to be fairly consistent across many different situations, which is a pretty interesting thing to consider. Now, the last slide that I want to talk about very, very briefly to wrap up this chapter is talking about the dual process theory. So we've kind of talked about the idea of how we think about things, how we make decisions, how we solve problems, how we put information together. And this dual process theory actually helps us tie a bunch of these concepts together. So the dual process theory states that we have 2 different systems or 2 different ways that we can process information. System 1 is a quick and automatic component of our reasoning process. This would be consistent with intuition. So this is where we would have fast solutions, fast gut responses. We could rely on heuristics. We're going to benefit from experience, and we tend to rely fairly heavily on emotional systems and things that we've seen previously. So we're going to rely on those emotional centers of the brain. So this is a quick, kind of like a quick and dirty solution, where it gets us the solution quickly, but it might not be the best solution. System 2 is more of a slow, effortful, and logical reasoning process. So it involves logical thinking, and it usually ends up recruiting higher order brain areas. So it involves other parts of the brain to allow us to make more rational decisions based on evidence. Now, we're not saying that either system is better. There are pros and cons to each of them. So fast versus slow, inaccurate versus accurate. It all depends on what we need in that instance. So we tend to use different systems in different ways at different times. So we might be using system 1 if we encounter a situation that we've experienced before, we think we know how to solve this, we'll just rely on a quick and dirty solution, no problem. Or if we encounter a novel situation, we've never seen this before, we have no idea how to proceed, we might have to rely on system 2. It's going to take us a lot longer, but we might be able to logic our way through this and come up with a new solution. So we're not saying that one of these is better than the other. We're not saying that we only use one or the other. We tend to use both systems sort of back and forth. And of course, the way that information is presented, the way that we face this decision can affect which system that we use. So sometimes we can force ourselves to take that step back, slow down, activate our system 2, and work through something logically. Or maybe we can try and go with our gut instinct and rely on system 1, depending on the situation.